Hi there everybody. Today we're going to look at algebra in shapes. Alright, so the idea of and as you can probably see from the diagram in front of us, we're going to put some algebra into shapes and they're going to ask you some questions which are going to ultimately probably lead you to trying to figure out what the value of x is, but ultimately there might be other variations on it. Alright, so essentially it's about the rules of angles. In this particular one, angles in a triangle, but they're looking for you to apply certain other rules and then include algebra into it. All right, so I'm going to walk you through a few different examples. This is the kind of concept that you need to be aware of. Certainly quite popular in the examinations. Okay, so if we have to work out an expression for the sum, this literally just add those three together. So this is our skills of algebra really. So this plus this plus this. So you've written it all out here. So x plus 5 plus x plus 25 plus x. Simplifying it, I've got 1, 2, 3x is there, and then 25 plus 5 is 30, so 3x plus 30. So that as an expression, all right, an expression, literally just algebra and numbers for the sum of the angles. Okay, normally there is a probably follow-up part of it or second part of it. In this case, it's going to be calculate the value of x. Okay, so to calculate the value of x, it doesn't really tell you an awful lot, but this is where you're thinking about, well, what does that mean? Well, the angles in a triangle, as you should know, and if you're not, please look at the lesson on angles in triangles, then these three add up to 180. Okay, so three angles add up to 180. So therefore I can form an equation because I know that these two, 3x plus 30, the sum of the angles equals 180. All right, so that's what I've got, 3x plus 30 equals 180. And of course at this point, I now use my two-step equation solving skills. And again, if you're not quite sure what I'm talking about in terms of solving two-step equations, then please look at the lesson on two-step equations. We're going to take away 30 from this side, so the inverse is going to come across. So 3x equals 180, take away 30. And then we're going to do, sort of simplify that, so 3x equals 150. And then divide this side, both sides by 3. So x is 150 divided by 3, so x would be 50. All right, so that's your value of x. That's answered the question. And again, it could be in an exam, they ask you to work out a specific angle. So if they wanted this one at the top here, then of course it'd be 50 plus 5, so that'd be 55, that angle over here. This angle would be 75, and this angle would be 50. All right. So let's kind of move on and look at another example. So what about an expression for perimeter? Well, the perimeter is just the three outside lines added together, so that plus that plus that. So again, relatively straightforward. We've got 1, 2, 3x plus 4. All right, so there we go. And then it's going to ask you some follow-up questions probably. So calculate the perimeter when x is 5. All right, so this is just really when x is 5, substitute the value in. All right, so I could put it in there, there, and there. But of course, we've already got this one. So let's just put it into this. So 3 times 5 plus 4 is going to give me 19. So my perimeter is 19. And find the value of x when the perimeter is 31. So this is the bit where you've got an expression of perimeter, and they've given you the answer, so you form the equation. Okay, so 3x plus 4 equals 31. So 3x equals 31, take away 4. And then therefore 3x is 27. And then divide by 3. And that's going to give you x is going to be 9. Okay. Right, let's look at one final example. Area. So again, this is about testing your skills of, yes, algebra, but similarly, you know how to work out the area of a rectangle. We'll work out area of a rectangle with times the width times by the height, or base times width, however you want to describe it. So this one times this one anyway. Well, because we've got two terms and two terms together, then this is going to form two brackets. Okay, two brackets. So x plus 5 times x minus 2. And arguably you could leave that. That is an expression. But it might be they ask you to kind of expand it. So we're going to use our skills of expanding double brackets. And again, if you're not quite sure how to do that, please look at the lesson on expanding double brackets. So you've got x squared, 5x, and then you've got minus 2x for that one, and then you've got the minus 10 for those two, which gives you that. And simplifying it, so x squared plus 3x there, so it's 5x, take away 2x, you get minus 10. All right. So that is an expression, that is an expression, that is an expression, but this is probably the simplified term. And like the previous ones, they're probably going to ask you to do something on top of that. So this is taking it to a slightly higher level, because this is a quadratic expression, but we're going to make it equal 30. All right, so make that equal to 30. Well, if I am going to solve a quadratic equation, this doesn't take the format that I want. All right, so please look at the lesson on solving quadratic equations. It needs to be in the form ax squared plus bx plus c equals 0. All right, so in essence, I don't want this 30 over here. I need to take it to this side and make it equal 0 before I look to solve it. All right, so that's the first step. So 30 is going to come across and become a minus 10 minus 30 is going to be minus 40. So we've got this. I am then ideally going to look to try and factorize it if it does, or obviously there is the formula or complete the square. So there are a few alternative routes for solving the quadratic, but I'm looking at this number to see if I can find two numbers at times to give me minus 40 that add to give me plus 3. All right. Well, I'm thinking 8 and 5. The reason I say 8 5s are 40, but the gap between them is 3. All right. So I think it's going to be plus 8 take away 5, because that's going to give me plus 3. All right. So there we go. X plus 8, x take away 5. All right. So that is your skills of factorizing a quadratic. All right. So again, if you're not quite sure how I've come to this, then please look at factorizing quadratics and solving equation using factorizing. All right. So at this point, I'm looking for the value in the bracket that makes it equal to 0 in this case or this case. So it's going to be minus 8 here or 5 there. All right. So they're my two solutions for this. However, we are talking about a length of a side here. So if I put minus 8 in here, well, I can't have minus 10 as a length, can I? And I can't have minus 3 as a length if I put minus in there. So this minus 8 as a solution is not right. Okay, it's not right. I can't use that one. So this is where that experience kind of comes in. Is it must be the value of 5 because I've got 10 and then 3. All right, and again, you think 10 times 3, I'm going to give you 30, isn't it? So it's got to be 5. So as length can't be negative, x must be 5. All right. I suppose at this point I could say, what is the length? Well, it'd be 10, because 5 plus 5. What is the width? 5 minus 2, 3. All right, so it's 3 times 10, which of course is 30, which makes sense. All right. Well, if you need practice on that, please do visit maths-school.co.uk and do some of the kind of questions which are on there. But of course, if there's anything that I've currently done, if there's anything there that I've currently done which you're not sure about, then please do revisit the factorizing quadratics, solving equations, and all those kind of aspects. All right. Okay. Well, thanks for listening.